Now we're looking at this is investigation 7 expansion. So this is investigation 7 expansion 7, number 5. And we're looking at static situations. And I'm going to show you the Norman-High shortcut. So let's put this here, and you have a 200 newtons down, and then you got two forces up. And I want you all, we'll film for a little bit, then I'll stop and let you guys work on something. We'll go to the sack of secrets, and then this guy's coming over here at a 30-degree angle. So this is 40 here. This is 30. This is a vector. Don't let the length of these are actual cables you're looking at. This is 200 newtons. Call this T3. This is T1, T2. And we're supposed to figure out what's T1 and T2. Now the old-fashioned way, and I think yesterday we talked about this a little bit, the old-fashioned way is to go ahead and do everything in the X by cosines. Do everything in the Y. This is how most textbooks will show you to do it. By sines, and you get two equations, two unknowns. You got to put it all together. You got to substitute in. You get inverse tangent. It's a mess. It would take the rest of the hour, certainly the next 30 minutes to do it. So I'm going to show you, or let you all figure out, a very fast shortcut. Because this is static. Because it's static, and that means nothing's moving. We can go ahead and use this shortcut. What happens when I take 3 vectors and I add them up head to tail? If it's static, you get 0 resultant, and so the geometric figure is a triangle. So what I want you to do, and I think we started this yesterday, but let's go ahead and do it for real now, is in the sack of secrets, I want your group to figure out how to rearrange these so that you get a triangle. And keep in mind, these lengths will not be true, but the angles will remain. You got to keep the angles. So make a triangle out of this, and then what you'll give me is your triangle with the correct angles. And by the way, these will not be the angles of your triangle. They'll be related, but they won't be the angles. Okay? So we're going to pause it while we work on the triangles.
Oh, really scared me.
I'm mostly concentrating on your drawing there. Okay. Approach the sack of secrets. Stick my hand in, just like Christmas morning. See what I got. And here we go. Now, Tio wasn't supposed to put his name on there, but he did. He's proud of it. He's probably making him dizzy, actually. Okay. Let's see what everybody has. This is what the class came up with. Unicorns of the world. And okay, so I'll edit all that. There's what the class got. And now let's talk about it. All right, so here's all I'm going to do. Here's a shortcut to solving this for those that are gone today. This is for Jackie and all those others out there. No last names. That aren't here. Who else is missing? Jamie's over there. Missing a bunch of people.
Garrett, Ryan,
yeah, Garrett's gone,
Dylan,
Ryan's gone.
Sarah.
Oh, Dylan's gone. Okay, cool. Sarah. So all those people that model UN people, this is for you. Cool. So there, and then this guy comes down like that. And then, see, all I did was I extended my MG, I brought this back, and I'm going to slide that down. Then, here is my triangle.
Mr. Askey, did you make the MG longer or did you move it?
I made it longer. The only reason I didn't have to, I could have kept it, but it would have made my triangle kind of small. I want it to be big so you can see it. All right, so there's my triangle, and now let's just show you, and you already did this, but to show the folks at home how we got the angles. All my British friends. All right, this is 30, therefore, two ways of looking at this. Let's do it this way. If that's 40, there's a parallel line, and that is what? By what? By what from geometry?
It's the same place.
Corresponding. So corresponding angles are the same. Therefore, what's this angle?
50.
Because complementary, right? Add up to 90. So all these little words that help show me ACT. If that's 30, that's 30, right? Why do I know that? Alternate interior. Therefore, that's 30 because of corresponding. If that's 30, what's that angle?
60.
Now, the three angles of a triangle add up to?
180.
Therefore, that must be 70. Okay, so now we know how you get that, how you'll always get, it's very simple how you'll always get that triangle. So let's now show you how to figure out what those tensions are, because that's the goal. And that's something from geometry, or no, something from trig now, called law of sines. The easiest thing in trig to remember. Law of sines. All it is sine of A over A equals sine of B. Sorry, little b. Keep it consistent. Sine of B over B equals sine of C over C. Side ABC, angle ABC. That's always the opposite side of the angle. So if that's, this I already know from our problem, this is 200. That's 200 newtons. So there's my 70. So I can now go ahead and solve any of these. There's my T1 rewritten, there's my T2, and these are the actual lengths, relative lengths of the actual force vectors. They're not cables anymore, they're the actual force vector. This guy is in that direction, and this guy's in that direction. All right, this guy we knew was down. That was our original 200. All head to tail. So, and we're making a video, and I've been criticized because I go too fast on these things, so if you want to jump in there, just slow me down. Because this is for somebody who's not getting it or somebody who's been gone. All right, so we go through here, and I say sine of 70 over 200. That's the opposite side. Equals, pick this one I guess, sine of 60 over T2. Solve that, cross multiply, and while you're at it, you might as well get this one. Sine of 50 over T1. And then you can cross multiply twice again if you want. And that's how you get T1 and T2. This is newtons. And that's how you work a statics problem, very common statics problem. You'll see it again and again and again.
What's sine 70 over 200? Do you have that answer just anywhere?
I don't have it on. Just cross multiply, I don't have it on me. Oh, well, good grief. You should get what the answers are in the back.
It says in class.
Oh.
I got 184.
184.
184.5, 163.
Okay, I get 163, 184.
Yeah.
All right, that's probably what you should get.